Here's another kind of different project here. This is a Bowers and Wilkins PV1 subwoofer. And the problem with this is it's blowing fuses, blowing the mains fuse. And if we look around here, we can see it's obviously had a bash here at some point. I know this has been in transit, so that's probably what's happened there. This is a very, very heavy unit. This is 20 odd kilos in this thing, and built very, very well. We'll see that when we take it apart. So whether the fuse blowing is related to this damage or whatever, I don't know. We'll find out. That was the report anyway, and of course I had to try that for myself. So we've got a couple of dead fuses there to prove the problem. So let's start to take this thing apart. We'll have to take this outer ring here. You know, there's drivers on both sides, so we'll take these outer rings off. We'll get the drivers out and start to see what's going on inside this thing. I mean, we're kind of obviously expecting some problem in the power supply area, possibly in the power amp, but let's get it apart and see what we can find. Alright, this outer rim's off then, and I have a feeling someone's been in here before, because the screws so far have been fairly loose, so it's like someone's been in here before fairly recently. Anyway, we'll get these screws off here, and then we'll get the drive unit out. So they're just coming away too easily. There's no resistance to starting these at all, which is not what we expect. Alright, so the screws are removed then, and they've kind of loosened this off a bit. So let's get the driver. Let's get the driver removed. There's obviously some steel metal work going on inside that the driver's, the magnet's attached to. But there we are. I'll get these terminals off, and it's a piece of work, that driver. Bit of engineering goes into that, and it weighs a ton. Nice piece of work, really. Anyway, we'll get that to the side and see what's going on. So inside we've got the other driver that we'll need to remove, and then there's two modules here. One of them's going to be the power supply, and then the other is the power amp. So we've got a bunch more screws and nuts and bolts to remove. We'll get the other driver out. We'll get this, the ball is in two parts, so we'll prise that apart, and we'll get into these units and start to find out what's going on. Well, that's us inside then. Both drivers are out, and the second one was equally loose, so I see, very suspicious someone's had a look at this before. Right, so inside we've got our mains cable here. We can see the blue and brown wires going in here, so this is going to be our power supply, and then there's a similar module here which must be our power amp. And if we spin it around, here's where our mains is coming in, and the line input's coming in here as well. So and it's all nicely sealed up. You know, they're doing a proper job here. There's our power amp section there, and you can see these are the speaker wires, speaker cables coming from that module there. Next thing we need to do then is, we've got these bolts around the outside. We'll get them off, and then we should be able to separate the two halves of the sphere here, and then we'll get into this power supply module, see what we can find. So these nuts have had a bit more, there's a bit more resistance to getting them started. So if someone has been in, at least it looks like they've not been in all the way, which is good. It means it's not been interfered with. So these bolts should now just slide. Well, they maybe need a bit of persuasion, of course. Let's find our hammer here and give them a wee. Yeah. Alright, so I had to spend a bit of time getting these nuts off and to actually start the bolts moving. And what I did actually is I put the nut on backwards and then tapped that with a hammer a few times to get them moving. So they're all kind of loose now, and they've been sealed in. You know, again, it's another sign of how well engineered this thing is. And I mean, look at the dimensions of the metalwork here. It's absolutely solid casting here. I mean, the tooling actually to come up with something like this is cost a fortune. Anyway, right, so we need to get these bolts out now, and we'll just start them with a screwdriver here and persuade them up. So there it goes. Bit of effort to get that out, but a good sign. Right, so I'll just continue around, do the rest of them. Got all these screws and bolts undone now, and I've prized the two sections apart. I actually put it on the floor, and I put my foot inside, and then I just pulled the top away. I've not got it completely separated right now. We'll leave that till later, but it's separated enough that we can get our boards out. So everything's free now, as I say. So this is our power amp section. 2 speaker cables, and then this will be our power in, and then we've got our power module here that we need to extract. So if we can get all these out, then we can start to look at these on their own and see what we can find is wrong. So let's get these on the bench and tidy up a wee bit, and we can see if we can find out what's gone wrong here. Alright then, so we've got the boards extracted, and we can see a bit more about what's happening here. So this is clearly our power supply. Mains comes in here, and we've got a bunch of filtering. Here's our rectifier, some relays, don't know what they're for, and then we've got an inductor or transformer here, and on this heatsink we've got a diode pair, and then there's a MOSFET. And I'm suspecting that this kind of arrangement here is maybe some power factor correction before we go into the main reservoir here and through onto the other power rails. And so I was looking for, you know, with this sort of catastrophic failure of the fuses, we're looking for something in this front area that's gone drastically wrong. I can't visually see anything, but of course we're suspicious of any kind of semiconductor or whatever that's in the path. And if I go in, this MOSFET here went to this right away, and we can see, if I can get my probe in, that MOSFET's a dead short. So that's certainly going to cause us problems, and that'll be the reason why we've got an immediate failure on the fuse. There's probably some circuitry around this thing as well that's failed, but that's the first thing we see. So we'll take the board out, we'll take that part out of the board, and just make sure we'll measure it out of the board, make sure that we're not reading some other thing associated with the board. We'll see where we go from there. We've got a lot of low-level electrolytic capacitors here. Pretty sure they're all going to be needing attention. And then this other board here is, we've got an off-the-shelf power supply here. This is a Bang & Olufsen power amp here, Class D power amp. So this is what's doing all the work in terms of the amplification and driving those loudspeakers. And then this board here, I suspect it's a kind of DC protection thing for the drivers. We're coming from the power amp through this board, and then we've got some relays here before we're switching to the loudspeakers. So I suspect that's what's going on there. But anyway, let's undo this board from its metal work. We'll make sure all these capacitors are discharged, take that FET out, we'll measure it, see how we go. Alright, and so FET's out of the board now, and it was a bit difficult because the screw is going through this heatsink and there's no access. So you know, really you would need to remove some of these parts if you wanted to get in there. But I managed with a pair of pliers just to loosen the thing off enough and got it out that way. And if we measure this guy, there's shorts everywhere you look. So that's clearly a problem. And the question is, you know, has something else gone that's taken that out, or has the fact that this is gone taken something else out? And we don't know entirely yet. There's a bunch of transistor and kind of diode stuff here that's driving that FET. That seems to check out okay. I suppose my next concern would be that we've got this driver device on the back here, and that could have been destroyed when the FET died. So we'll see. We'll maybe need to replace that as well. And then of course we don't know what's downstream. I've checked these FETs here and they're okay. So hopefully this is just what's gone wrong and we can replace this guy and bring ourselves back to life. Now we've got a bunch of capacitors here, a bunch of low-level capacitors, and there's a number of different values, which is always a nuisance. And they're not so bad. You know, there's a couple of ohms in that one. About 3 ohms there. So you know, they're on the wrong side of where they should be. So we'll get a list. I've already got a wee list here of these values, and we'll replace them, freshen everything up, and we'll do the same on the other two boards as well. And hopefully, changing the FET, doing that, will bring this thing back online. A slight change in direction here. What we find is that this FET is obsolete, of course, and so you're looking for some equivalent, and we'll have to order it up. It's going to take a few days to get here, and then we don't know if we've still got other problems. So what I've done is using, these are some FETs I had here anyway, kind of juicy guys. So we'll install that for now, and that'll tell us, you know, if there's anything else gone wrong that we need to consider. And if we get a good result by using this guy, we'll go ahead then and change all our capacitors and everything else and see how we go. So that's the plan now. We'll install this heatsink and other bits and pieces back in the board. We'll go and see if we can power it up without the fuse blowing. Right, so there's our heatsink back installed with our new FET, etc. there, so that's fine. And I found here that we had a series resistor, this guy here, and it was open circuit. So we've replaced that again just with what I had available, so I've got a much higher power part here. And I think what's happening here is this is an inrush current soft start kind of thing, where we've got the resistor in series with everything else as we apply power, and then these relays then bypass that resistor once everything's up to voltage, just to limit the inrush current due to this big capacitor here. So I think that's what's been going on, and this guy was open circuit. Now whether, you know, is it because the FET's gone short that this has gone open? We don't know. We'll see what happens. So I think we're ready to put some power on this now, and we'll just see how it behaves. Alright, I think we've got a result here then. If we power up our DMM, we're all powered up here, and if we check the voltage across our big reservoir, 370 volts, so that's healthy enough. And then there's 3 main power supplies. It comes off this board. We've got an 80 volt and then a plus and minus 12, and if we look at our 80 volts, just about 82 volts, so that's cool. And then plus and minus 12 is down in this connector. So there's our plus 12, there's our minus 12. So, and this is with the power amps connected up, so no issues there. So we're in good shape then. That's a good result, and I think the next thing we'll go and replace all these low level capacitors on this board and on these boards, and you know, we should be in a good position after that. Right, so most of our low level capacitors are replaced on the main board and also this board here. And I thought it was worth just having a quick look at this power module here. So this is a B&O, Bang & Olufsen, ICE 500A. And I think this is basically an analog design here. I recognise some of the comparator part numbers, etc. But we've got a bunch of these capacitors here, and if we do our usual kind of measurements on them, we can see there's 5 ohms ESR on this guy, and some of these other guys are not very clever either. There's a couple of ohms there, and there's a few I've removed already, which are reading pretty rubbish. So we'll go ahead, we'll replace all of these capacitors here, and then we should be in a position where we're kind of looking to put this thing back together. So if we take a quick look, we see that this power amp is still available as a module. Here it is from Profusion, and best part £100 for that module. So we're kind of lucky that so far we don't think there's a problem with that. But just interesting to see it's still available. So there we go. Right, anyway, let's get back and we'll start to put some of this stuff back together and get some power on it again and maybe get a signal through the thing. Okay, so all our low level capacitors are replaced now on the main boards as well as the power amp board, and we've got them screwed back into their metalwork ready to go in the unit. Just before we do that, I roughly traced out the schematic of what was going on here. So our input AC is coming in through, got a bridge rectifier here, and then this small capacitor is these two guys in parallel. The inductor is this guy, and then we've got the FET and the diode, the FET that we replaced. And this is a power factor correction type circuit here, so we've got a small capacitor there, and then the big capacitor, we only supply current to that based on how we switch this FET, and that means that we can control the power factor, and a power factor near 1 is what we're looking for, so that our voltage is in phase with the current. So that's and of course that FET being short, essentially the inductor's a short circuit to DC, and so any fuse in line there is just going to pop. So that's what's happened there when that FET's gone short. And the fact that it's referenced to ground here, so the fact everything was short to ground, that saved the circuitry that's driving this thing. That wasn't damaged, and the reason is that everything just shorted the ground. So kind of lucky in that mechanism there. Right, that's we're ready to go now. We'll get this stuff back in the unit, put a signal on it, see what happens. Right then, so I've got the power supply and the power amp just loosely installed. It's connected up, and I've just got a few screws to hold it in place. And again, I've just, with this drive unit's connected up, just placed in there. It's connected, but it's not screwed in. And I've only got the one drive unit in there at the moment. And the unit's powered up. And if we apply a signal, then, of course, you're never going to hear it on this microphone, but we can see the movement on the camera there, and I can vary my frequency and amplitude as well. And that gets quite fun there. The bench is kind of bench, or the camera's vibrating away there in sympathy. So we're working okay then, and so I'm just going to leave this powered for a while and make sure everything's stable, and then I'll screw it completely back together, and we can have a final check before we wrap up. So that's the next step. Just leave it running for a while, and we'll come back after that. Alright, so we're all back together now, everything's completely bolted together, and we're up and running. We can see the cone here, rattling back and forward quite happily, and its neighbour on the other side's doing the same thing. So we're really in good shape now. Now we did comment initially that this unit had received a bit of a bash. We could see a little kink here in the enclosure, and we wondered if that was related to the fault. And I don't think so. We don't know the reason why that FET failed, but I don't think it's got anything to do with this. And I was kind of thinking to try and straighten this out, but what I realised is that this enclosure is a kind of dual skin thing. So the interior skin is fine, so the integrity of the actual cavity inside this thing isn't compromised in any way. This is more a cosmetic thing, and you know, I'm kind of not inclined to touch that now. It's really, if I was to do that, it would be a bit of an experiment, and I might do more damage than good. So I think it's best just left as an honest bash, and won't affect operation in any way. So we can have a little play. We can crank up our level here, and if we turn up the frequency enough, we'll maybe hear it. But you can see that vibrating away there quite violently, and I can feel it in my chest. That's 20 hertz we're running there. There's 50 hertz, 100. And there's 150, and it starts to tail off above that. So there we are, we're working quite happily, and I think time to wrap this one up and get this back to its owner.